Hello, everybody. Today we are going to talk about linear functions with Luna the Math Cat, who wants to be visiting today. So, linear functions. A linear function is a function whose graph is a non-vertical line. So we don't want any vertical lines. We're going to look at everything else. Horizontal lines are okay. Diagonal lines are okay. No vertical lines. So a linear function can be written in the form y equals mx plus b, where m is the slope and b is the y-intercept. So we've talked about this a little bit in class. Got a little bit ahead of ourselves here, but so here we are going to use the graph to write a linear function that relates y to x. So we've got these 4 points that are on our graph right here. And we can put a line through those just like that. Okay, and we want to write an equation for that. So we know that a line is going to be of the form y equals mx plus b, okay, where m is the slope, and this number right here is the y-intercept. Okay, so now, so it just so happens we have the y-intercept here, 0, -3. So this is a very simple problem. We can just substitute that in right here. So -3. Okay, now we just got to figure out the slope. Well, on this graph, we can figure out the slope pretty easily by just picking 2 points and saying, okay, I can make a slope triangle here. I'm going to rise 3 and I'm going to run 2. So my slope is going to be 3/2. And there's my equation, y equals 3/2 x -3. Don't like the way that looks, so let's rewrite it. Okay, so that would definitely be one way that we could do it if we had those points on there. Okay, so use the table to write a linear function that relates y to x. Okay, so first thing I would do with this is I'd probably graph these points. So we've got -3, 9. There's -3, 9 is going to be right there. I think this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. And -2, 7 would be right here. -1, 5 would be right there. 0, 3 would be right here. So we'll go ahead and here's our line that we want to make. Looks something like that. Let's go ahead and make it a line instead of a segment. Okay, so there we go. Now, again, I always like to write down the formula, y equals mx plus b. Okay, so the first thing we're going to do is we're going to figure out the slope here. So my slope, pick 2 points that are here. Whoops, that's too big. Let's undo that. Okay, so I can do the slope from here to here. That goes down 2, so it's -2, and it runs 1. So my slope is going to be -2/1. My y is just my y, my x is just my x, and then my y-intercept. So I look right here, there's my y-intercept, that's 3. So plus 3. And then I would just go ahead and rewrite the equation, clean it up a little bit, -2x plus 3. And there we go. We have a function that relates a y to an x. A straight page here, so let's delete that page. Okay, so now you're going to go ahead and do these 2 problems. So here I have some graph points. Over here I've got a table. I would like you to go ahead and find the equation of both of those lines. And then, so pause the video here, go do those, and then jump back on and make sure you got them right. Okay. So, here, let's do this first, because I like to graph things. Let's take this, put this over here, and Get rid of those. So we'll have another graph over there. Now this one here, we can go ahead and write down our formula, y equals mx plus b. Okay, and I can figure out my slope. So here's my line. I always like to have the line on there. So my slope is going to be right there. Whoops, I don't want a line segment. Okay, we're going to go down 1 to the right 2. Minus 1 plus 2. So this is going to be minus 1/2 right here. Okay, so y is going to equal negative 1/2 x. And then I just got to find the y-intercept. And the y-intercept is right there. That's negative 1. And I'm done with that one. There's my equation. Y equals negative 1/2 x minus 1. Okay, now I can do this without graphing it, but graphing it kind of makes it easy. It doesn't take very long to graph these. Negative 2, positive 2 is right here. Negative 1, positive 2 is right here. 0, 2 is right here. Oh, this is an interesting one. 1, 2 is right here. So if I draw this line, that's that line right there. So we have a horizontal line, which is okay to do. This one I can actually do this in my head really easily. Remember that y equals mx plus b, right? So I need the slope and the y-intercept. Well, the y-intercept is right there. It's 2. So that's easy. The slope on this is very easy too. It's a horizontal line. The slope is 0. So if I put a 0 here, that just cancels out this whole thing and just leaves me with y equals 2, and I'm done. And yes, that's in slope-intercept form, because technically it's y equals 0x plus 2. Okay. Okay, you're controlling an unmanned aerial vehicle, a UAV, for surveillance. The table shows the height y in thousands of feet of the UAV X minutes after you start its descent from cruising altitude. Write a linear function that relates y to x. And then interpret the slope and the y-intercept, graph the linear function. So I'm going to do the graph first since I've got these points. Oh, and I don't like this. Okay, so this down here, here's what we're going to do. Oops. We're going to do... I'm going to get rid of this right here. I'm going to put a new scale on here. And let's see. Let's just make that go away. Okay, so now my minutes are going to go 0, 10, 20, 30. So let's go 5, 10, 15, 20, 25, 30, like that, 35, 40. Okay, so in X minutes, 0 minutes, we're at 65,000 feet. That's going to be like right here. Okay, then it starts to descend. So in 10 minutes, it's at 60,000 feet. So that would be right here. And at 20 minutes, that would be at 55,000 feet. So that would be right here. And at 30 minutes, that would be at 50,000 feet. That's going to be right here. Okay, so you can see there's my descent line right there. Okay, let's find an equation for this. So we'll go back to y equals mx plus b. Okay, and now I got to figure out my slope and y-intercept. Well, the y-intercept is obvious. The y-intercept is right here, and it's 65. So this is going to be plus 65, whatever that is. So the only thing I really have to figure out is the slope. So you can see this is linear. I can choose any 2 points that I want. And I can calculate the slope using the slope formula. Remember, m equals y2 minus y1 over x2 minus x1. So I'm going to go ahead and choose these 2 points right here because I think that'll be easy to do. So the difference in the y's, that's going to be 60 minus 65 over 10 minus 0. Okay, so that's negative 5 over 10, which is negative 1/2. So there's my slope. I'm going to go ahead and put that in right there. There's my equation. Y equals negative 1/2 x plus 65. Piece of cake. Now, you got to interpret the slope of the y-intercept. So what does the slope mean? Well, the denominator's in minutes, okay, and the numerator's in height in thousands of feet, okay. So this is going to mean the slope is going to be it's going to descend 1,000 feet every 2 minutes. That's what the slope is going to mean. Okay? Remember, this is in thousands of feet. It's going down 5,000 feet in 10 minutes. That's going down 1,000 feet in 2 minutes. Okay, now what does the y-intercept mean? So the y-intercept was its initial cruising height. Started out, it was flying at 65,000 feet, and then we caused it to descend. So there you go. Anything else down here? Nope, that's it. Okay, the earnings y in dollars of a nighttime employee working X hours are represented by the linear function y equals 7.5x plus 30. The table shows the earning of a daytime employee. Which employee has the highest hourly wage? So let's actually kind of figure out what does this equation mean right here. These are the wages when they work X hours. So this person is going to get $30 just to start, and then is going to get $7.50 an hour. Okay, now this might be, normally people are not paid that way. Normally they're paid by the hour, but this could be a bonus that they get for having to come in at night. So right away they'll give you a $30 bonus, and then they pay you your hourly wage after that. So what's going on here? Well, let's see. We could figure out the slope of this. The slope, remember, is y2 minus y1 over x2 minus x1. So I can pick 2 of these. Let's pick this one and this one because that should be pretty easy to do. The slope is going to be 50 minus 25 all over 4 minus 2. So the slope is going to be 25 over 2, which is 12.5. So this person makes $12.50 an hour. They got $12.50 after 1 hour. Guess what that means they make at 0 hours? They get $0. So, who has the higher hourly wage? Well, it's the daytime employee has the higher hourly wage. Okay, because they get $12.50 an hour. Whereas the nighttime employee gets $7.50. Okay, so now they do get a 30-hour bonus. So, if this person, if you were going to be called into work for, say, an hour or two, this would be a better deal for you. Anything longer than that, then this would be a better deal for you. Okay, so write a linear function that relates a daytime employee's earnings to the number of hours worked. In the same coordinate plane, graph the linear functions that represent the earnings of the two employees. Okay. So the daytime employee's earnings, if I write an equation, is going to be y equals 12.5x. And the y-intercept is 0. Okay. Because they didn't get, I mean, you can just look at it. They were getting $12.50 an hour. And then obviously if I go back to 0, which would be the y-intercept, that's going to be 0. So if I was going to graph this, I would have the daytime employee would be at 0 right here. And then at an hour or 2 hours, they'd be $25. And at 4 hours, they would be at $50. And so they're going to have that equation right there. So that's the daytime employee. Okay, now the nighttime employee is going to start out at 30 and get $7.50 an hour. So let's do this one in orange here. So they're going to start out at 30. It's going to be like right here. And then, let's see, $7.50 an hour. That's $15 every 2 hours. That's going to be 40. Or no, that's going to be 45 after 2 hours. So that's going to be like right here. And another $15 after 2 more hours is going to be 60, which is going to be like right here. And then after another 2 hours, that's going to be 75. That's going to be right here. That's where those lines are going to cross. Okay, so I go make an orange line. I'm going to go right here. So if you work 6 hours or less, it's better to be on the nighttime program. 6 hours is your break-even point right there. Okay. So there you go. So we're going to do 1 through 23 odd. That is only 12 problems for you. We're going to do that in class next time. I look forward to seeing you later. Have a great evening.